But we can hold on for a few more minutes to give people time to trickle in, and then we'll get started shortly.
Is my volume all right?
Volume is all right, but you're cutting out.
Is this better?
Yes.
So far, so good. Say a few more words, Victor, just in case.
1, 2, 3, 4, 5, 6, 7.
All right,
Very
perfect.
clear.
Thanks.
Okay, thank you.
If our other presenters want to just say hi to test their microphones, that's probably a good idea as well.
Hey, this is Will Law. Good morning. How's this microphone?
Well, you're showing up as unmuted, but I didn't hear anything.
Likely because I didn't say that much.
Oh, okay. Now we can hear you. Cool. Thanks. By the way, for everyone speaking, it sounds like MeetEcho still has this bug where it requests the microphone only when you unmute, which means that it takes a few seconds for the microphone to start working. So once you click, just wait for a bit and then start talking. Otherwise, the beginning will be clipped out.
David, this is Will Law repeating my mic test. I was pretty sure it was too short last time. Can you just confirm this is okay?
Yeah,
This
you're
is
crisp now.
Yep.
Okay.
Also, we can hear you.
Are we still waiting, or do we want to get started?
Probably good to get started.
Okay.
You want to talk, Bernard?
Sure. This is the Webtrans Working Group meeting at IETF 110. A few meeting tips. This session is being recorded. You need a data tracker login to attend, but it's automatic, so you don't need to fill in the blue sheets. You can join the session Jabber Room via the data tracker meeting agenda. Just click on that. Please use headphones or an echo canceling speakerphone to avoid echo, and state your full name before speaking so we can get it in the minutes. Just a few little tips on MeetEcho. You enter the queue by pressing the raise your hand button, and you leave by pressing it again. When you call on, you enable your audio to be heard, and as David said, it may take a few seconds to actually turn it on. And you enable it by unmuting and disable by muting. You can also enable video. It's separate from audio and not required. So here's the note rel, which is a reminder of IETF policies. And that's in BCP 79. Please read it. And there's definitive information listed in the documents below. If you want advice, you can talk to the chairs or ADs. A little bit about this meeting. Yeah.
Sorry, on the previous slide, I just also, as usual, want to highlight the IETF Code of Conduct, which this meeting is operating under. We've never had any issues in the Webtrans working group in the past, but let's keep it this way. Always be nice and polite and willing to listen to other perspectives. Great, thanks.
Thank you. So the agenda is up. There is a Etherpad, which we'd like people to take notes in, and the Jabber Room. I believe we have a volunteer for JavaScribe. Is that right? And note takers, is that true?
I don't remember. If anyone has already volunteered, please speak up now. All right, Ellen Frindell is in the Jabber as Jabber Scribe. All right, thanks, Alan.
Okay.
We do need minute takers, though. Could we have 1 or 2 volunteers, please? All right, so our Kinnear will do some note taking, but he's also presenting. Could someone be backup? And that way it's always easier when there are 2 people, especially in KDMD. We are waiting to have a volunteer, otherwise we're not going to start the session. I know we all have email to do, people, but come on, please. This is how we do business.
Want to draft somebody, David?
Lucas just volunteered. Thank you so much, Lucas.
Okay.
Much
Thank you very
appreciated.
much, Lucas. You're a gentleman and a scholar. All right. So here's the agenda. We've gone through most of the preliminaries from the chair. We'll have a W3C update from Will, and Victor will talk about web transporter of HTTP3. Eric will cover HTTP2, and then the chairs will wrap it up. So over to Will.
Okay, thank you. Good morning. This is Will Law from Akamai. I'm also joined by W3C co-chair Yanivar Brewery from Mozilla. So you can all read faster than I can talk, but I'll go through these bullet points. We just have 2 slides here on a quick update. A couple of key decisions and PRs following the last IETF update on November 16th. So at that point, there was the IETF single transport decision. So we've echoed the ramifications of that through the W3C removal of quick dash transport as an option, while maintaining the web transport constructor. The removal of mixins to concentrate on a more concrete API around HTTP3. Mapping of web transport methods to quick protocol actions. Datagrams are now a duplex stream. In other words, they have a readable and writable interface. Considering making a similar change on the bidirectional unidirectional streams so that there's symmetry and so that we can support a stream of streams functionality. Back pressure available on datagrams now. The app can set a time window at which it flushes stale data from the underlying queue. The web transport example has been updated to use more modern JavaScript using for await methods and piping for pretty clean data flow through the system. And then there's been much smaller housekeeping, fix some races, algorithm updates, etc. I'll pause at this point. Do you have questions on any one of these bullet points? Okay, I hear no questions. Next slide, please, Bruno or David. So we have some issues currently debatable. We don't have resolution on these, but to give you some flavor of what's being discussed. First is to make send stream and receive stream a subclass of writable stream and readable stream. There's arguments for and against this. In terms of pooling, there's a request for a constructor argument to web transport, so you can decide if your connection is going to be dedicated or shared with other HTTP3 flows. And there's complications around that, obviously, because even though the application might want it, both the operating system on both the client and the server also have to support that, and how to get that information back to the app. Some debate about which stats we can provide and which stats we should provide, especially in the face of pooled connections. Work around defining error codes, and also work around some generic interface names. And if we're hogging generic interface names, then we should make them more specific. And then lastly, a request from the W3 side to the IETF. Can the scheme to be used for web transport connection be finalized? We had a work group call, our last one on March 2nd. We didn't have a call for consensus on this, but I can report that those present, Bernard, David, Victor, Yataka, and Martin, who I think are on today's call as well, have expressed a preference for HTTPS. No more input from our side than that, but we do request, if possible, that the scheme be finalized so we can proceed with the API. Thank you. Questions on this slide or any other questions for the W3C team? Okay, David, back to you then. Thank you.
Thank you. All right, so we're going to turn it over to Victor for web transport over HTTP3.
Good morning, everyone. I'm Victor Vasiliev. I work for Google, and I am the editor for Web Transport HTTP draft, which we adopted in the time between the last interim and this meeting. So now that we adopted the draft, there are lots of issues we need to solve, and all of those issues are on GitHub. And if you haven't, you're welcome to you're encouraged to go to this link and comment because there are lots of open issues. So my goal for this meeting is to get us to the state where we figure out the most important issues that prevent us from shipping an interoperable version of web transport over HTTP3. And the primary reason for that is Chrome is currently shipping web transport over Quick as an origin trial, and we're basically under incentive to unship that as fast as possible, so that we no longer use something that is deprecated. So let's go over issues. The next slide. So the first issue is the syntax for server-initiated bidirectional streams. The current syntax is roughly whenever you open a stream, which is server-initiated, and bidirectional, you just assume that the stream belongs to a web transport session. You put the session ID in the front of the stream, and then you put application payload on both sides. We do that because HTTP3 does not define any specific semantics for server-initiated bidirectional streams. In fact, it explicitly bans those, and we allow those. So there is an observation that if we define them this way, we will not be able to use them for anything else. So the proposal is to make them use essentially the same syntax as client-initiated bidirectional streams, which is a sequence of frames. So I wonder do people have any opinions? Alan.
Hey there, Alan Frindell from Facebook. So aren't client-initiated bidirectional streams identified by them being a connect request?
They are identified.
They have a frame type. I'm sorry, I'm forgetting.
You're in the queue. Go ahead.
This is okay.
Yep.
So it looks like the client originated ones look like they have a frame type, but they don't technically have a frame type. You just have a frame type, and then it's the rest of the string. And the same would apply here. Is that right?
Yes, though, like I would separate that's a separate question. That's a separate issue. That's I actually think is next slide. But the proposal here is that we should make the client initiated and server initiated behave the same.
Sure. I think that's reasonable as long as they're distinguishable from other types of streams for the client side.
Alan?
Yeah, so do we want or need, and maybe this is not a question for web transport, but does there need to be sort of Datagrams falls under this as well, which is that like everybody who wants to extend server-initiated bidirectional streams in HTTP will also face the same decision, right? And if we want to encourage all extensions to sort of follow the same thing, so different extensions can be demultiplexed in the same kind of way. So I don't know if there should be, sort of general guidance for extension writers so that that we don't have to keep redoing this in every HTTP extension.
David?
Are you speaking, Victor? Because we're not hearing anything.
No, I'm asking if you're the next person in queue.
Oh, yeah, no, I did myself. So not speaking as an individual, I think it makes sense that, like, similar to datagrams, where we have a draft that is just how do you use datagrams with HTTP3, because the original HTTP3 specification doesn't have semantics for them. Maybe one thing we might need here is an incredibly short draft, which is how do you use server-initiated bidirectional streams with HTTP3? And it carries a setting, because all of these things need one. And then it's you use HTTP frames, and that's it. And then we reference that from this document. Would that make sense?
Yeah, that would make sense. I'm not completely sure separate draft is required as long as we pick an approach that is compatible with what is with further extensibility.
That's reasonable, as long as we tie it to a different setting from the web transport setting, so it's possible for any other extension to HTTP3 to do this without having to have a dependency on web transport itself.
Yeah, I'm not even sure it's that. It's like, as long as the two extensions do exactly the same thing, which is use frames, sequence of HTTP frames, you're fine.
They are, but I'm saying, like, in terms of dependency on what setting the other extension needs to send. All right.
Sure.
Ian Sweat is next in the queue.
Hey, I'm not completely sure you even need to talk about settings in all circumstances. It seems like this is more a case of, how does one extend HTTP3? And I think if we make this decision, which is totally sensible, other people are probably going to want to make a similar decision, both because it's also sensible and because it's compatible with this. I mean, we could write a separate document, but given there are a wide variety of use cases out there, this is more a case of, like, it's best practice not to hog all the server-initiated bidirectional streams, right? I mean, and this is the obvious way to do so. That's that I can see. So I don't know. I mean, if this already existed and HTTP3 wasn't so far along, I would say we could shove this in the existing section that's already there. But at this point, yeah, I don't know. Maybe Martin has a thought on where it should go. But I should say, I don't think it really matters. I think either way, we should move forward with a consistent design here. It's just a matter of, do we need to also stick that decision somewhere else?
Go ahead, Martin.
So I was I was going to say exactly what Alan just put in the chat, which is we don't really own HTTP3, and we'd have to talk to the people who do in order to get that to happen. I think it's probably best if the HTTP biz working group defines a generic document. The document should probably also describe what it is to use a client-initiated bidirectional stream as well.
Well,
Even though that's fairly obvious.
I mean, I think the core HTTP3 document specifies how client-initiated streams work. That they carry frames, and then that's left to extensions to do different frames, isn't it?
I think it says that they carry requests, which are comprised of frames, right? So that sort of level of generic use is probably something that it's sensibly done there. Obviously, with people from this working group going over there to do the work, but yeah.
That makes sense. Okay, as chair, I can take an action item to reach out to the HTTP working group chairs to see how they feel about this and what we should do about this work. Because it sounds like our options include having this part of this document, having this part of a separate document that's in Webtrans, or having this part of a separate document that's in HTTP. Because similarly, the datagram document ended up in MASC, not in HTTP at the request of the HTTP chairs. So this, I could see that happening as like this document being in Webtrans as a potential option. At the end of the day, these documents are pretty short and simple. As long as we get them done, I don't have a strong opinion for where they live. Alan is next in queue.
Yeah, there's one more point that I raised on issue 23, which is not totally related to how bidirectional streams work exactly. It has to do with the fact that unidirectional streams are identified by a stream type, and bidirectional streams are identified by a frame type. But other than, if you ignore that those two things are different kinds of types, they otherwise look the same at the beginning of the stream. And I have an implementation of the current draft, and I end up taking advantage of the fact that they look the same. But if anyone ever actually added a frame type with the same identifier as the unidirectional stream type, then my beautiful symmetric implementation would break. And so, and I think this is a little bit of a weirdness that came out of how HTTP3 decided that there are stream types and frame types, and those decisions have been made. But it might be nice to reserve the unidirectional stream type number in the frame type space. Maybe we can put that on a separate issue if it's not directly related here.
Thanks, Alan. I think let's have Bernard and I circle back with other chairs to see where we want this particular work to land. And I think that'll be a great issue for that document whenever it shows up.
Okay, so the next issue is the use of type value frames and how exactly they are defined. So the way we're currently defining frames that converts a HTTP request stream into web transport stream is by introducing a type value frame where you have type and then you don't have any length, because the entirety of the rest of the stream's body is assumed to be the value. And so currently all defined HTTP3 frames have tag length, type length, and value. But when we talked about this in Quick Working Group, we agreed that extensions could potentially define type value without length. And the original intent was to make a data frame that would go to the end of the stream, so you would so you could avoid extra level of framing. And on the issue discussion, it was not clear whether people believe that length can be omitted, or whether the length always has to be there, but you can set it to 0 and ignore it for those kinds of frames. And the question here is, we currently don't have length, should we add it? David?
So speaking as an individual here, I personally think that this would be a useful feature that's like generically in H3 that we had talked about, which was if the frame length is 0, the frame goes till the end of the stream. There was discussion of adding that into HTTP3, but that got turned down at some point. Maybe this is something we could do generically. but that would have to see if people are okay with that in HTTP, or if we want to do something that's just specific for the web transport frame type.
Yeah, so do people have other opinions? Ian?
Yeah, I don't have that strong an opinion on this, although I did have a mental model that this was what we were going to do for extensions like this, to use type value without an explicit length or a length of 0. But this is another thing where if there was some magical document that the HTTP working group produced about HTTP3 and how you should do extensions, it'd be kind of nice to shove what we think is the best practice into that document. I'm fine for this to go either way at the moment. I don't think either way, this is like kind of a weird special case. Because in one case you don't have a length, or in the other case you have a length of 0. And in both cases, if you don't understand what the type is, your parser will immediately fail. So, you know, these frames that we're talking about are special in some sense. They are not standard HTTP3 frames that exist elsewhere. So that's kind of why in practice I think either can work.
Alan?
Yeah, I mean, I think just recognizing that either is possible. Again, like, so I do have an implementation, and so I had to go in and write special code to handle frames that have no length. So, but it was like, 3 lines of code or something. It was not ridiculous, and I do view them as mostly equivalent. And even if we wanted to say have an extension to the extension frame that had other things in it besides, then you would have to add a length there. So there's maybe a reason why you could just start it with length 0, but then even if there was an extension to it, it would probably have to be another frame type anyway. So I don't think that really matters either. So I don't know. We could just pick one or decide what best practice is.
Lucas?
Hello, can you hear me?
Yes.
Okay, Lucas Pardew from Cloudflare. I'm kind of confused by this because my implementation, if it saw an extension frame with a code point it didn't understand, would want to just ignore it and then move on to the next frame. But I don't know how long the frame is to ignore. So maybe I'm just missing something here, but I don't see how I can ignore a thing that I don't know what it is, when it doesn't have a length.
I think my answer is this in general. This is like why we define a setting, and you don't send that frame without a setting. So if you set a setting, you promise that you will not ignore web transport frame.
But if I don't set the setting and you send me one, then you've broken my connection. I don't know.
Yes, that's why you're not supposed to send it if it's not negotiated.
Sure, but the current HTTP3 extension story is that we just ignore unknown frames. So yeah, we in a perfect world this shouldn't happen, but I can't detect that from a generic HTTP3 implementation because I don't implement web transport, so I don't know what you're doing.
Yeah, I mean, I guess my answer is it's like it will be a fatal error to send that frame when both parties have not negotiated web transport. And I think the text explicitly tells you to not do that. Anyways, Martin?
Yeah, I was just going to answer Lucas here. There's general provision in H2 and H3 for settings that change the way the protocol behaves completely. So in this case, you would have a setting that says, I understand that frame X means whatever it means, whether it's a 0 length and then everything after that frame is something other than frames, or whether it's just the frame type and it doesn't have a length. Whatever we decide, you can have that meaning baked into a setting. And so if you saw that frame type without the setting, it would just be a regular frame at that point that should be ignored and is probably going to be treated like an error by anyone who actually understands the frame type. But the idea would be that you use the setting to ensure that you don't cause bad effects on the other side. I think that's completely workable. You just get to pick which outcome you want. What I did want to say though was that Alan's point about stream types and frame types is kind of relevant here, because the bidirectional streams are going to be just stream types more than frame types, and we can potentially exploit that somewhat.
And I assume that means that's like speaks in favor of not using length here.
Yeah, I
Because-
don't think length gives you anything at this point, because a length of 0 doesn't help, because what the generic parser that Lucas has will do at that point is try to read the next byte as if it were a frame. And maybe that'll work and maybe that won't. And the result is undefined probably. So we have to rely on the setting here.
All right. Thank you. Eric Kinnear.
I think not having a length is a reasonable thing to do, and I especially like the framing of it that Martin said, which is essentially, you know, everything after this is no longer frames. But it is worth noting that as you're trying to move this data around, in the past with earlier versions of HTTP and HTTP1, etc., having something that extends until finished is a little bit more annoying than knowing, hey, I've got about this much more coming, and I should make provision for that in my protocol stack as I'm trying to figure out how much to allocate or how much space is going to happen. So if we're in a place like I think we are here, where what's coming next is going to have its own structure potentially, or could be otherwise defined, then that's not such a big deal. But if we're talking about making this a super generic thing, having something that just extends until it doesn't is kind of annoying in some ways.
Alan?
Yeah, just thinking about it and listening, I think I'm in favor of not having the length being the signal to say everything else on this stream is unframed. And I think maybe the reason that makes the most sense to me is that there are frames already defined in H3 for which 0 length is valid. Both data and I think settings can be blank. I'm not saying that not having length is a signal, but I guess I like the idea of this is sort of defined as a different thing and not assigning a 0 length for this frame to mean something much different than 0 length for other frames means.
David, I think you're next.
Yeah. I just wanted to say that, like, my earlier comment about trying to do something generic clearly doesn't work based on this conversation. So I completely take that back. I think having something that's specific to a web transport frame without the length and that is keyed on a web transport specific setting seems like the best way to go, in my opinion.
Martin?
The trigger word. I don't think that it's something that we can avoid in terms of generic stuff for the bidirectional streams. I think that we're going to need to have something generic for that purpose exactly. But aside from that, yes, the frame stuff, yeah, it's going to be, you're going to need to know that when you see this frame type, you stop processing frames, and that's going to be on a per frame type basis.
All right. It sounds like we have some form of agreement that at least the length is not helpful here. So we can move on to the next issue. Next, Oh yes, the URI scheme. So basically, we have roughly two options: use HTTPS and use the completely new URI scheme for web transport, and that could be URI scheme for web transport over HTTP or web transport in general. So, as Will mentioned earlier, we had a conversation in W3C, and basically, there were many things said, but the short reason is that there's no particular reason to define a new URI scheme, because as far as we can tell, web transport resources are just HTTP resources. They do require custom syntax, and they do require you to use a very specific HTTP method, but that is not new to HTTP resources. So we should just use HTTPS, and that would make it work well with the rest of the stack. The main objection was there were subtle differences in which web transport behaves in HTTP in terms of how it handles things like cookies and HTTP off, and namely, it currently does not. And at least in W3C draft, we agreed that it would not send either. But I think overall that is different concern from the question of how those resources are identified. Does anyone have any questions for the mic? Martin.
Got in the mic line to give you support. This seems pretty reasonable what to do. I noticed Jonathan Lennox asked, why was the WebSocket scheme as a separate scheme? And the history there is basically, WS and WSS are examples of what not to do more than what to do in this case. And so, yeah, we should probably just treat it as a different method on the same HTTPS resource that we have thought about previously. It would be different if we're talking about quick transport, I think, but now that we're taking this path, this is a much easier decision in my mind.
All right, does anyone else have anything else to say?
As just jumping in as chair, I'm not seeing any opposition to going with HTTPS here. So and haven't seen any on the issue. So unless someone wants to speak up now or on the list, I think we can assume consensus on this one and move forward with HTTPS for now.
Well, it does not look like we have any opposition to this, so let's move to the next issue. Oh, so this is now, so the previous three issues were very important for interop. Those are less critical, but still important. So the issue 10 is mostly reconfirming what we already have, which is we made at some point decisions that web transport would not expose stream IDs. And this was originally in quick transport. That idea made complete in web transport over quick. That idea made some sense because the IDs are consistent. But when you add HTTP and you add proxies in the middle, this makes no sense whatsoever. So I just wanted to reconfirm that we are not going to expose stream IDs as a part of the protocol or application surface. Does anyone object to that? Luke?
Oh, hello. So I made the original ticket, or at least Nikhil works with me, who made the original, try to expose them. For some context, we wanted to know the ordering between different streams, so we wanted just a way of knowing the creation date, more or less, and possibly, and that's the main thing that we wanted. That's not necessarily possible now with HTTP3 transport, with pooling specifically. So it's one of those things that we'll just have to drop or add a custom way of doing that within web transport.
Yeah, so I was thinking whether it is possible to preserve some way to preserve ordering without necessarily preserving the idea of the exact stream IDs, like without making them referenceable. And one question I have, when you're interested about ordering, do you care about relative ordering, or does this ordering need to have no gaps?
So initially we did the thing with every odd and even one was a different type of stream, just as a way of, saving bytes, right? Like instead of having an explicit header. And we were abusing the fact that quick streams are monotonically increasing, like it just +4 every of the same stream type. Again, that's not possible because now if there's a gap with web transport, you don't know which protocol, you don't know if it was an HTTP3 request, or you don't know if it was for a different web transport session. So at least that use case doesn't work. And yeah, there's no way of knowing how many streams may have been created before your stream if there's packet loss or whatever. Our solution is just to add a header on top of every stream, and that may actually just be acceptable. Just tell applications to define their own stream IDs.
Okay. Jennifer?
Hi, can you hear me?
Yes.
Hi, this is Jan Weber in Mozilla. I just wanted to make sure that I understood that we can still, I think ordering is going to be important in the API because message framing is going to be typically hard to do for JavaScript developers and get it right. For instance, I've experimented with 2 different ways to wrap. Something we get asked a lot is how to wrap a sort of a WebSocket-like API on top of web transport. And I pretty much see 2 ways to do it. One is to map it to a bidirectional stream if you want header line blocking. And the other one is to wrap it on a transport itself where you're sending text messages as individual streams. And then if you then send, for instance, like a large data blob, you would send that as a separate stream as well. So in those cases, it seems that preserving the ordering of sending on the receiver side is critical. And I heard some things that sounded like, I just want to clarify if we're still able to guarantee that order, or is there something in HTTP3 that prevents that?
I think if you send on explicit different streams, you're explicitly guaranteed that order will not be preserved in which you reserve, because otherwise you would just have header line blocking if you wanted to preserve order.
You're talking about the data within the streams, but I mean the creation order of the streams. I was very happy to find in the quick spec, it says that successive streams of each type are created with numerically increasing stream IDs, and a stream ID that is used out of order results in all streams of that type with lower numbered stream IDs also being opened. And the way I interpreted that was, if that's true, then if we can carry that forward to the API, if you do for await on transport.incoming streams, you're guaranteed, as long as you don't await for completion of these streams, at least their appearance on the API should be in the order they were sent. Is that not true?
I don't believe this is true because, one, since this is multiplexed, you don't know if the streams in the middle are even your streams. And two, this is still head-of-line blocking, because if it was, imagine you're doing HTTP, you would be able to receive an entirety of HTTP request with higher stream ID and process it and send response before the previous stream, if like only the previous stream was lost. So from that standpoint, it doesn't really make sense.
Well, but you can solve it. It won't be blocking, because all you have to do, if you get a stream ID that is that skips, that's newer than you expected, the receiver can then create the underlying streams for the missing numbers, and if they come in later, provide data.
Sure, but you don't have, as I said, the first reason is you don't have guarantees that those are web transport streams.
But yeah, I don't know the networking stack that well, so apologies. But if someone else could clarify that, that'd be good.
Yeah.
I can attempt to clarify, perhaps. So the important property here is, so in Quick, when an endpoint decides to create new streams, every like subsequent call to I want a new stream will give it a higher ID. But if I'm sending, let's say for bidirectional streams, as the client, I get like stream ID 12 and stream ID 16. I can open stream ID 12 and send some data in a packet, and then in the next packet send 16. But the packet with 12 can get lost. So the fact that I send them in a given order doesn't mean that they'll be received in the same order on the other side. And so from a web transport perspective, I think if what you want is for the API to enforce this ordering, as in, give me the next stream, let's say, and you receive 16 but not 12, and then you say, well, I'm going to wait for 12, I think that would really diminish the benefits of Quick, because the point of using multiple streams is that a loss on one stream doesn't mess up another stream. So I would, like, speaking as an individual here, be pretty much against having that be a blocking relationship in the API, because I'm sure that there are applications who absolutely don't want that. They prefer to get the data for stream 16, even if 12 is on the way and might come in a bit later.
Okay.
And then sorry, go ahead.
Okay, but we're talking about API now, and I think the API doesn't force the application to choose, because you can for await over the incoming streams, and you can decide at the app level whether you want to download each file to completion before beginning the next one, or you can download them all in parallel. So the point at which you expose these things, since you mentioned the numbers, if you received 16, you can create a sort of dummy 12 that if you were to wait for actual data on it, it might never arrive. And then you create both 12 and 16, and you'll start receiving data on 16. And it becomes an app problem if it wants to wait for 12.
So you could do that. What I would say is, so there's a bit more details by Victor on the issue, but given that we're now over HTTP3, which is a multiplexed protocol, and some of these streams might be non-web transport, we're going to need a new namespace, because we're not going to want to expose the number 16 to the web transport application, because that could leak some information about the other things that are happening on the connection. And so then the question becomes, if we're all in agreement that we don't want a blocking relationship in the API, then the question becomes, do we add this new numbering inside web transport, or do we just do what Luke was saying, which is we don't offer this, and applications are free to, at the start of their stream, just add a number in there, and that way they can know the ordering at that level. I would be inclined to, given that this is pretty simple to do, to push this on to applications, because not everyone might need it, but that's just my personal 2 cents. And I see Martin is behind me in the queue.
Yeah, so I think you covered off most of that. Unless you want to make the application aware of the existence of things that are not for it, then you have to accept the fact that when you get the 16, you know that 12 exists, but you don't know what 12 was for. And so you can't signal that because it might be for something that you don't want the application even existed in the first place. So you can imagine you have your stream of streams, and you can have some sort of tombstones where all of the streams that existed but weren't for you exist, but then you're still leaking to the application that they did exist. And I don't think that's appropriate at all, based on what we've discussed. The other way to get around this one is potentially the notion of a dedicated connection for the purposes of a given application. And at that point, you can start to expose these things, because that dedicated application knows that every single stream is for it. You can make that stream available to the application, even though you haven't seen any of the contents of that stream yet. So the problem that we have with this particular case, where you have multiple users of the same connection, is that you don't know whether this particular stream is for this particular application until you've seen the contents of it. And you know it exists, but you don't know anything of the contents yet. And so that's where you end up. I think at this point, yeah, like David said, let's just make the application developers' lives harder. It's kind of a cop-out, but it's, that's where it's at. Unless we want to go to dedicated streams, that is.
Bernard, you're next in queue.
Yeah, just to say, I think it's worth having an issue, because there are a number of cases where really it is the application's responsibility, and this is one of them. It's not always clear, like people seem to be, in some cases, relying on things that they really need to do in the app. An example of that also is in the API, at least, we were arguing about whether to make acts visible or not, and we decided not to, because it's really up to the app to handle datagram reliability, but not everybody's been clear about that. So, Jan Ivar, to answer your question, if each stream is a message, you really are asking for Quick to give you an unordered reliable service, and that means you do have to, as an app, have to take care of ordering yourself. It's the best for an unordered service.
That makes sense. Who should take the action item to file an issue here? I think even if we don't change the protocol, we should have text in the document that specifies which properties we're getting, such as, or which ones we're not. For example, the fact that streams can arrive out of order.
Just Victor, since he's the editor.
All right, Victor, can you take the action item to file that issue, please?
Isn't this essentially like just this issue?
So you're super weak right now. Yes, this is essentially this issue, but
yeah.
This issue is in W3C. We probably want one in at IETF as well.
No, I refiled it as a IETF issue. Issue 10.
Oh, my bad. Yeah, sorry. All right, then we're good. Thank you.
All right.
Haven't been at the
yeah,
queue, but before we move on, let's drain the queue. Janivar?
Yeah, so I just want to get clarification. I think we're happy to work on the API part of it, but I just want to understand that the language I found in the quick spec then, that the under streams of lower numbers than the ones that are received are not opened in HTTP 3. Is that not a property anymore?
They are opened, but before we receive data, we do not know which web transport they belong to. It's the same issue. Actually, next issue is very similar in nature. I think yeah,
but then but once you receive data, and then you know which web transport it is, at that point, an API could decide to open lower number streams for web
Yes, but at
transport.
this point, you introduce head of line blocking, because if you don't have stream 12, but you have stream 16, you know that stream 12 exists, but if you acquire data from stream 12, now you're head of line blocking.
But only the application would require data.
No, HTTP stack needs data to know how to route that signal.
But if that never arrives, then what part of web transport is blocked?
If right now nothing, if we require streams to go in order, then all of the future streams would be blocked, because we would have to wait for every stream to order them.
If I might jump in with a clarification here.
Sure.
So Janivar, it sounds like the feature you're asking for is, hey, I received this client-initiated stream and I'm happy with it, but it told me that there is some other stream that I haven't received yet that I want to send something on. If, as the server, you want to send data on a stream before you've received anything on it, then why not just use a server-initiated stream? Like, the whole point of in the quick mindset of client-initiated stream is that they're the kind of stream where the client's going to speak first. So in HTTP, that's a request, for example. Since Web Transport offers also unidirectional streams, I think we have enough arrows in our quiver here to not require this specific feature of, I want to send first in the other direction of a stream initiated by my peer.
Well, I think the model here is that when you create a stream, all the data inside it is order guaranteed, right? So, but if I have data and I want to split it up into 2 streams, then I'm no longer guaranteed the order of delivery of that data, because I could send a few bytes followed by, I could send a lot of bytes followed by a few bytes. But the surfacing of those 2 on the client side, it would be beneficial if we could surface them in the creation order. And I don't see that we cannot, and I also don't see why that would block anything. And the goal here would be to provide, because framing is hard in JavaScript, and streams, as far as I understand it, stream IDs is an implementation of framing that applications could benefit from, where we could give them these guarantees. And I'll work on clarifying why I don't consider that head of line blocking, but if there's something in Web Transport that would block from that, I guess we can look at that in future issues.
Okay, thanks. I think if you could write up an example of like how the application does this, and maybe we can take it offline, because this sounds interesting, but maybe it deserves its own conversation that might take a bit longer.
Right, I have a fiddle actually of I'm mapping a WebSocket API to a Web Transport I can post in chat for people who are interested.
Cool. Yeah, please do. And but if you can add as much detail as possible on the issue, I think this will be we can keep the conversation going there to make sure we understand what you're trying to accomplish and see if there's a need for a change here at Webtrans or not.
Great, thanks.
All right, thank you, Luke.
Hello. So I think at a higher level, this also applies to this next issue we're going to cover, reset stream, is that in my use case, we're using Quick for mobile platforms, or at least we have. So Android app, iOS app, whatever. And then for Web Transport, for web support, we need to use Web Transport. There's just a few quick features that we want to use or have been using that just don't map nicely to Web Transport. Stream ID is one of them. Where on native platforms, we could use the quick stream ID because it is exposed to the application if we're using raw quick, and reset and some other things that are more connection oriented. So that's maybe just a higher level question. Is Web Transport trying to expose the quick API, or is it trying to expose a subset of it? And if we're trying to have a subset of it, then a lot of these discussions can be, what subset?
My intuition is that it definitely has to be a subset, because I don't think we can implement like 100% one-to-one perfect mapping. Or, I mean, we could, but some of the things we would have to do, I'm not completely sure are 100% worth it, because Quick has a lot of semantics, and some of those semantics are entirely dictated by the fact that Quick is a transport protocol that has to handle all of the transport issues. But our goal is in general to implement as much of it as possible and expose as much of the semantics of Quick, especially semantics relating to ability to have things that are unreliable and avoiding head-of-line blocking as possible. That's my general view. So I think the question is definitely on what subset, and the general answer is as much as possible, but we might have to make some compromises here and there.
It is worth mentioning, for example, that HTTP3 does use stream ID. So if you wanted to build HTTP3 on top of web transport, it wouldn't be possible. Again, I don't know if that's an issue. It's just a lot of these little things that you're limiting the application to.
Yeah, so I guess this does leave us with general question: do we want applications to emulate that, or do we want to emulate that by ourselves? And for stream ID specifically, I feel like it is much easier to leave it up to the application, with the general philosophical principles that some application would not need it, and if they don't need it, you're just wasting bytes. And if they need it, it is not that hard to build a system that does that. As you said, you just add a header in front. So that's at least my perspective. Is there anyone else in queue? Alan.
Yeah, I'll go quick because I know we spent a lot of time on this issue. I feel like that maybe there's an opportunity where, you know, we're hearing potentially from people who are using apps or have written applications, and they're telling us what they want from the transport, and we are maybe ignoring them because we want to build sort of the simplest thing, sort of the batteries not included version, and apps end up implementing a lot of stuff on top. And I just want to encourage us to listen to the use cases and consider maybe adding some things in the transport layer. I don't want to add tons of complexity, but you know, if this is one, like, I don't think you're wasting a ton of bytes. If applications are like, so much more is possible, if you can tell us about the order of the streams in my session, then, you know, I would not be opposed to building that potentially into the protocol, and then, you know, people will use it if they need it or not. You know, anyway, it's just, we should be listening to what the users are asking, so they don't implement, every app doesn't have to implement it over and over again.
All right. Thanks, Alan. Tim, if it's about this issue, let's keep it short, and we're cutting the microphone after Tim here so we can move on to the next issue. But go ahead, Tim.
Sure, yeah, it is about this issue, but I just wanted to say in the WebRTC world, we came across the same problem with, and we ended up solving it with a very lightweight protocol that, which just slots in the header in the beginning of a stream and just puts a couple of things in that lets the API label a stream so it can actually manage that kind of behavior. And it's turned out to be really, really useful for the things I'm doing. So I kind of, if something like that was possible without having too big an overhead, I'd go for it.
Thank you. So I don't think we have arrived at the definitive agreement, because while there is definitely agreement that we cannot expose the quick stream ID, but the question now becomes: do we want to simulate something like quick stream IDs? And I think that's probably worth discussing more, but probably at a later date, and probably not for the most immediate interrupt draft. Issue 31 is very similar in its root cause. We currently expose reset stream to the application, and we expose the reset stream error code. And the problem is you can receive and process reset stream before you receive the data on the stream that associates that stream with a web transport session. And the question is, well, first of all, do we want to expose reset stream and make it reliable? And the second of all, if we do that, how do we do that? And I was wondering do people have opinions on this issue? I should mention that there are actually 3 options. There is do not guarantee reliability, or actually no, you have to expose the fact that the stream was reset, but anyone has anything to say for the microphone? Martin.
Just for you, Victor. I'm going to argue for the first option because that's far less complicated. It's exactly in the spirit of reset stream. And the only problem here is that if someone is mixing web transport streams and request streams, and one of those gets reset and the header doesn't get through, the header that allows the server in this case to identify this as a web transport stream for this particular web transport or request or what have you, then it doesn't get to do anything with that stream. It's just a stream that appeared and had to go away again. And that's fine. It just means that in those cases where the sender or the endpoint that creates streams creates a stream and then resets it too fast, then the other side never hears about that stream, and that's okay. That's perfectly fine.
Right. Thank you, Luke.
So from an application level, if I'm using web transport, I create a stream. I could write, I don't know, a megabyte of data and then use the web transport API and close it with error code 5. I think it's a reasonable expectation for a developer that error code 5 is going to make it to the other side, especially if you've written data to it. But what really happens is if there's any packet loss, that code could be dropped. The reset stream could win. The reset stream frame could win, and because none of the data was received on the stream, actually, more specifically, the first data frame wasn't received on the stream. It'll just be dropped completely. So it seems like a poor, maybe not a poor API, but maybe something that could lead to problems where application developers just expect these codes to be reliable, but just due to packet loss, they might not be. And I don't think that's an API we want to expose.
Is it specifically about the reset code error code being reliable?
Yeah, I think it's just the code being reliable. I think and the fact that a stream existed. I guess this goes to the ID question as well. Like, does the receiver need to know that a stream even ever existed? Because if you reset a stream and if you get a receiver reset stream and you never receive data for it, you wouldn't know what protocol it was for, so you would never know it would exist.
Understood. Martin.
One, because this is physics, right? And so physics states that if you use reset stream for this purpose, you don't get to learn about the code sometimes, and that's just how it works. And so the question is whether we build an additional facility into the protocol in order to carry these messages, or we consider the option for those people who absolutely need this to have a dedicated connection and get these messages, because that's the only way that I can see of getting these messages through reliably. And yes, you're going to lose your error codes occasionally. Too bad.
Can you hear me?
Yeah.
Okay. Because for some reason it's saying that my audio is gone. My question, I would say that it is possible to just make it so reset stream error codes always arrive if you're not pulling your connections, and that to some extent that's a solution.
I was going to say there is an option here that does work potentially, and that is to reserve reset stream error codes for web transport. It gives you some ambiguity if you have two tabs in the browser sharing the same transport, and you get two different web transports to each of those different tabs on that same connection, then a reset stream will propagate to neither tab, because you can't allow cross-tab communication like that. That's the only case I can imagine being a problem.
Yeah, so but that's again the pooled case, because if you have only one connection, there's that doesn't. I feel like we should, regardless, reserve some space for web transport error codes. And the reason for that is so that we can distinguish web transport error codes from HTTP error codes, regardless of what we're doing.
Yep.
Jennifer?
All right, sorry, my audio is back here. Yeah, I just want to echo the, I think we're gonna have to find some way to make these APIs based on this a little more predictable. And I'm hopeful that we might be able to do so at the API level, but it seems like this particular one, it would, if there's a way to, I guess if once you get a newer stream, you might know that there was one, an earlier one that could have been reset, for example, that never existed. And but the semantics here bother me a little bit, and it sounds like they're embedded in a protocol that you can reset something, you can initiate something and then pull it back without the recipient ever knowing about it, and that's going to cause a jump in sequence numbers. Or is it too late to? Is that true, or can the sequence number be reused in this case where it was reset before sending any bytes?
No, but as we mentioned before, reset takes it out of stream space for underlying HTTP connection, but it doesn't. But that space doesn't really exist for individual session.
All right, and just to add, because I saw this in the chat, in one of the chats, I think just conceptually and fundamentally, quick streams are not ordered. The fact that in Quick they have a stream ID that is sequential is an implementation detail of Quick. Maybe at the end of the day, we just need to accept the fact that they are not ordered, and that is like Quick does not provide this property to upper layers, and WebTransport does not provide this property to higher layers. I think at this point, and let's move on. I don't want to spend too much time on this specific topic, but if there is a need for this, I think it would be nice for someone to articulate what the use cases that would clearly benefit from this, because since Quick doesn't offer this property, for us to add this property into WebTransport would be non-trivial. And as with most things, we don't want to add complexity unless we have to.
Can we move on to the next issue?
Victor, you want to keep going?
1 second. Yeah, I think I think we should move the rest conversation to mailing lists and GitHub. So this is so there is an issues 28 and 29 are roughly the same issue, but from different perspective. Basically, the observation is is the question: do we require client and server to buffer incoming streams if they're associated with a WebTransport session that is not yet known? And basically, if we answer yes, we can let the client open streams in parallel with establishing WebTransport session, which would cut down on latency. And similarly, it is unclear how to make server streams work without doing that. So I think we should buffer in both directions. But I was wondering if people have opinions or anything to say on this matter. Bernard?
Yeah, I agree. We've encountered this in other things such as WebRTC, and buffering is a good idea. The only thing to keep in mind is you might want to have limits on the buffer. That's about it.
Yeah, that's I assume like as long as you don't read past the beginning of the streams, you would get flow control blocked on all of those streams. Does anyone else have anything else to say? Yes, we might want to limit number of streams. This is a different issue, which I think is currently not here. Yeah, that's true. There is a separate issue for, in general, how do we limit the number of streams. So next slide. Oh, this one is an interesting one, and it comes from proxies. So assume that like you are connected to a reverse proxy, and that reverse proxy is connected to a backend, and you receive a go away from a backend, meaning that roughly you want to indicate somehow to the application, and now somehow your reverse proxy should indicate to the application that to the client that the session is being drained and it will go away soon. The question is, how do we do this, and do we want to support this in protocol? Do people have any thoughts on that? Alan?
I'm going to say something that Martin can't disagree with. I don't know. So I just want to say that this is it's very important that we find a solution to this problem. because we have essentially something very similar to web transport running today, and the application that uses it, they have a sequence of streams that run. We do this over H2 today. They have a sequence of streams that belong sort of as a transaction, and they need to away, like when their backend or one of the intermediate proxies starts draining, they need a way to, we need a way to signal, like, please don't start any more new work here, and wrap up what you're doing, but don't prevent the creation of new streams that were needed in order to complete sort of the transaction that were associated with that session. So I don't have a concrete proposal here, but I foresee, I think, sending something like a go away type frame on the connect stream of the web transport session being an adequate solution. But I'm open to hear other ideas. But I just wanted to highlight, I think it's an important issue.
All right, Martin.
I think I'm going to agree with Alan here. It's like the way that we've been conceptually go away is that new requests stop. But this is not new requests, because we're talking about something that is it's like the next level down. And so when the way that I would imagine this working, similar to how Alan's proposed it, I think, would be that the go away at the H3 layer says no more requests, please. But you can continue to create web transport streams associated with existing web transport sessions. Within the sessions, however, you're going to need a way to say, stop making new streams. And so there might be a need to have some sort of thing, like Alan said on the connect stream, saying, stop making new streams. And that might be the way to solve it. I don't actually know if that makes sense, as opposed to just giving the application some ability to build that capability itself, though. Not enough detail yet.
So it sounds like we in general agree that we should solve this problem somehow. But we need to decide on specific solution, and we should probably do that offline. Next slide. Yeah, so this is so issue 33 is roughly currently when we have a connect stream, when it gets closed or reset, this indicates that the web transport session is completely gone and all of the streams belonging to it must be reset. And the question is whether we should keep that semantics or whether we should remove it or relax it so that streams can continue to drain even after it's closed. And from my perspective, I think that semantics of everything completely going away is useful, because in particular, imagine you're a web application and you have a browser tab and you have an object that's a client object. If you want to be able to hard close entire web transport session, because if you close the entire tab, there is no more data to flow, like everything is gone. So you should be able to throw out entire web transport session without needing to do anything like a drain. But I do understand that people might have different opinions on this. And if you have different opinions, please go. Please talk at the mic. Yeah, Alan?
Yeah, so I raised this issue after I implemented, or mostly implemented last week, and I found I did not need in my implementation to track all the streams that belong, which streams belong to which session, sort of inside the kind of transport stack, for any reason other than this reason. So, but because I need to reset them when the connect stream goes away at sort of the library level, I would have to like keep an extra list of things, which and I would maybe sort of offer that the higher level would probably already have that. And if the browser tab is going away, it can also reset those streams. So I mean, I see the advantage of just like, yes, it's tied to the lifetime of Connect, and I can just nuke this one thing and everything else goes away. But I don't know, sort of just pushing. Somebody has to track that, and where do you push it? And I don't know. I never know if bringing this up is an argument for or against. But if you liken this at all to the way that push works, sort of the independent stream can go away, and the life of the dependent stream is not tied to it. It was in Speedy and in early drafts of H2, but then that requirement was removed. And so you're allowed to sort of destroy the parent thing, and then the child things continue with their own life.
I can kind of see this argument. I guess the question is, so I definitely think that the browser should close, reset the connect stream. It is not clear to me whether we could relax that requirement on non-browser implementations, because as you mentioned, for the reasons you described, because now I'm thinking about how it would work in our implementation, and like I can see the similar thing. Luke?
I just want to bring up, similar to a previous issue, that only the creator of the stream knows that it's associated with a connection. So it seems like whoever created the stream should close it whenever the connect stream is closed. Otherwise, you're left in this case, there might be a dangling stream that, the other side doesn't know it's supposed to be associated with this now defunct session.
Yeah, I agree. And especially given that we consider things like buffering, you might end up in this weird situation where the connect stream is entirely created and destroyed, and now there is this like web transport stream that is buffered and does not belong to everything, and like, yeah. Yeah, Lucas makes a good observation that if we allow staying streams past destruction of connect stream, that makes us less able to rely on extending connect stream for like random control semantics like sending goaways, which is one thing we discussed. So is anyone actually in the queue right now? Because if you're not in the queue, please, yeah. So I think for now we should keep it as is, and I don't want to strictly close this issue because I want to see how I will feel about it after I actually implement it. But for now, let's keep the requirement that everything gets reset once Connect Stream is closed. Next slide. We're finally reaching this one. I think this is the last issue of the day. The question is, how do we talk about pooling and support negotiation for HTTP web transport over HTTP free pooling? And we have at least 3 proposals. Option 1 is, I think, what is currently in the draft, which is roughly, we defer this entire problem to the clients. And if you're a client, you should know whether the server supports pooling. And if the server does not support pooling, it will turn your request away, and this is a fairly simple model, but the problem is that it puts burden on all clients to know whether server supports pooling or not, and the failures in non-support pooling is fairly is basically almost fatal. Well, it's not fatal; you can handle it, but there is option 2, which is a settings negotiation in which both server and client agree on whether connection is a connection entirely dedicated to one web transport session, if it's a regular HTTP connection that supports web transport, or if it doesn't support web transport at all, and that is described in PR25. And there is also proposal to have a limit on max web transport sessions, and you can just set it to 1 if you want dedicated. And I don't think this actually entirely does anything, because while it prevents you from pooling web transport with other web transport, it does not tell you anything about pooling web transport with regular HTTP requests. But that's another option that was discussed on the issue. And so I am personally somewhere, I was originally wrote PR25, and then I was convinced that option 1 is much easier, but now that people have brought up that the client might not necessarily know what it's doing, I am more inclined to do option 2 again. But I do want to know what people's opinions are on this issue. Let's go into the queue. Alan.
Yeah, so I was the one who wrote the max web transport session thing and the issue, and I think I've since retracted it. I think it's a good idea. So, but I don't think 1 is either. I think we need something like 2, where the server can sort of declare what it's going to support. I think PR25 it's sort of weird. I'm not sure that the client needs to be as involved in sort of like agreeing on what to do, right? Like the server either can handle HTTP and web transport at the same time, or it can handle only one web transport thing, or it can handle multiple web transport things. But it seems like that if the client, the client's going to make a decision about does it even want to try to pool, and then it can look at the setting it got from the server and decide if the server doesn't allow pooling, then the choice is made for it. So I'm just not sure that the design in 25, it might need some more massaging there, but I think I'm more in favor of option 2.
So to explain the reason 25 requires a client to signal intent is you want to avoid a situation where the client connects to a server and the server is basically supports only one web transport protocol and nothing else, but the client expects to be able to send regular HTTP streams. And from that standpoint, you want to avoid that. You want to know the client that it can't use a connection for that. But yeah, I understand that. Bernard.
Yeah, I also would like to speak for option 2. I think option 1 would be just, particularly if it's linked to other things in the API, like what stats you get. I just think it would be very awkward, and I think option 2 is a lot cleaner.
Understood. Thank you. Yutaka?
Hear me?
Could you repeat this again?
Can you hear me?
Okay, now we can hear you.
Yeah, I don't understand why the client need to send the intention to the server, because the client in any case need to wait for the first settings frame, so the client can do a decision making with the server support and the web developers in the intention or client's intention. So that I don't know if we need to have a settings from the client to the server?
I think I agree with you. That is a detail we will need to think through more, but yeah, we might be able to get rid of the client signal and reduce client to only support does not support web transport, and then the server can have both pulled and allow pulling and dedicated mode. Thank you. Anyone else have any opinions for the microphone? Dragana?
Ah, it works. Do you hear me? Yeah.
Yes.
Yeah. You will need a client indication if you want to use web transport or not, if you want to separate HTTP3 connections and transport connections to the same origin. So if you want to, if you don't dedicate from an application that you want a separate connection for HTTP3 and transport, then you basically can pull them on the same one. You cannot, and the server only wants to support one of them. It's complicated. I'm not really sure if you want to have a server that listen to the same port and have the same origin and actually want a separate connection for transport and HTTP3 and builds the application that doesn't that allow polling. That will be the case, if you understand me. Probably not.
Yeah, so the reason I want to add dedicated mode for the server is that there are developers who want to run only exactly one application on their server. So it's kind of like you cannot send regular HTTP traffic to the same connection, but
you want to have the connection to the same origin with the same port on HTTP3 and on web transport.
Yes.
Yeah. And in that case, if application is not built to disallow pooling, you will need to indicate, I want to open this connection only for HTTP3, and I want to open this connection only for web transport. Otherwise, the browser don't know where to send the data. Yeah, that doesn't matter. Yeah, I can try to explain that in an issue.
Sure. Yeah, the issue has much more discussion, by the way. I think it does. There is a lot of discussion on the pull request about whether we need that. So everyone is welcome to chime in.
Okay.
Thank you. Martin, you're next.
I'm going to come out pretty firmly against having an explicit dedicated flag. This decision to use HTTP3 means that when you make a connection, you're making an HTTP connection, and there are numerous other options available for the server to not, say, accept HTTP requests or not accept other web transport sessions on the same connection. Now, I think probably option 3 is okay in that sense, but simply saying I'm not going to accept HTTP requests is kind of not really in the spirit of using HTTP. And so we have 421, and that will allow a server to do things like say, I've got a certificate for this thing, but I'm not willing to speak for it. And you have the option of putting your web transport endpoints on a different origin. And I don't think that there's any reason why that would not work for anyone because of the way that this is going to integrate into the security model. I don't think there's any reason why you need to have the same ostensible origin for the web page as the web transport connection. So I'm sort of struggling to justify even having a dedicated thing from the server indication, and I support Yutaka's point about the use of web transport from the client side.
Yes, so I can see the argument for like not needing to make it dedicated to HTTP, for not needing a separate feature to reject HTTP requests when you can send 4-to-1, because if you're sending HTTP requests, then you already know where you're sending them. The question is, yes, it's more interesting, the question of whether you allow pulling web transports and whether the server should be able to indicate that it wants to do that or not, because the client currently can, and it is not clear whether the server needs to be able to signal that or not.
Yeah, so I think the key point here is resource management from the server perspective. And so having a maximum number of sessions and potentially having things like the maximum number of streams for each session would be useful controls to have here. But having the level of dedicated, not dedicated, with HTTP, without HTTP, it is not really consistent with any of the other design decisions that we've made, and probably unnecessary as well.
I agree. So I feel like Eric Kinnear.
Eric can answer.
Well, I just wanted to I think the idea of having, max sessions and maybe max streams in session and stuff all makes sense. I just wanted to clarify my understanding of what you're saying, which is it's not even so much that this is about being quick versus HTTP, but rather we're saying someone who controls the endpoints for this is able to set up endpoints that will respond to requests for web transport sessions or for HTTP resources as they choose. And that doesn't need additional explicit signaling in web transport, the protocol, because if you wanted it to go, if you wanted to say, I only will answer things like this, then only answer things like that. Is that kind of what you're saying?
Yeah, I mean, if you wanted to make sure that you only ever got web transport requests to a particular server, then only provide web transport links, as it were, to that server, and then there's a good chance that that's all you get. And if you do happen to get an HTTP request, you can send back a, 406 method not supported or what have you.
Yeah, thanks.
It looks like we don't have anyone else in the queue. It sounds like we should continue discussion on the issue. Everyone is very much welcome to comment, and I would say strongly encouraged. If you have an opinion, please do. It's issue 34 on GitHub. And this is the final issue we're not going to discuss here, is datagram flows, and specifically the syntax to encode them. And the reason and this is very similar to server-initiated stream IDs, but fortunately there is already a dedicated draft in which we can discuss that, and the draft is a mask working group, which meets at the same time as this working group, except tomorrow instead of today. So if you have opinions on that matter, you're strongly encouraged to come there, to go to attend that meeting. I think that's it for web transport over HTTP3. There are some issues related to pooling, which I did not go over because I think at this very point in time we should get version without pooling, sort out the ether issues before we talk about how we do things like research management in pooled web transport sessions. And with that, I hand it back to the chairs.
Yeah, so Eric, you're up.
All right. We have what appears to be functioning audio. Can we go to the next slide? All right, so we'll make this pretty quick. One of the main goals here is to mirror what we're doing for H3. So everything that we just talked about and decided upon or made progress on, hopefully we can inherit here. One of the things that we'd brought up in the past as a, do we need this? How much do we need different fallbacks? That sort of thing, was what happens when Quick, or really UDP is probably the more likely thing to struggle with firewalls initially, is blocked. And so we know that there's going to be some networks where Quick doesn't work, and that may be because of a misconfiguration, that may be because nobody really expected UDP traffic to do anything. That may be somebody who's deliberately trying to say Quick does not work here because I don't want it because of X principled stand. But we know that there's going to be some places where Quick is blocked, and our use of Quick for HTTP traffic for requesting resources in general falls back to HTTP2 and does that over TLS and TCP. And so the question becomes, we can deploy Quick and have this fallback plan for HTTP and web browsing. What do we do for web transport when this situation occurs? Next slide, please. So we have a couple of different choices. One choice is just have it fail. If you try to connect and Quick is not a thing, then you don't get web transport. Another option that's been brought up and discussed a bit is to require you to bring your own fallback. So that means something like WebSockets. Would we want to implement web transport on top of WebSockets? We've already been talking in this meeting about doing WebSockets over web transport, so we could maybe do WebSockets over web transport over WebSockets. There's all sorts of interesting layering that happens there. It seems as though there's also a bit of an aversion to trying to map web transport on top of WebSockets, which I think is probably well-founded. And the third option is to fall back to running something like web transport, but over HTTP2. Next slide, please. So in looking more practically at how we would actually do that, and is it even worth doing, Web Transport, the framework, which is that kind of first document that isn't the mapping over H3, defines a set of capabilities, some of which are required and some of which are optional. The kind of design philosophy behind trying to bring web transport to HTTP2 is make sure that we can still do all of the required things and as many of the optional things as possible, but over H2. And obviously the big difference here is that brings with it TLS and TCP, that removes the ability to be unreliable, that brings in some ordering guarantees, which previously we did not rely on and likely should not. The end result of this is everything that's required is still there. Those optional ones aren't. The question becomes, is that useful and is that something that's worth spending time on? So to the next slide. The next couple of slides talk about a couple of key design approaches that I think would be worth taking. And this is something where I think we're looking for feedback of, are these the right statements to make? Are these something that we want to do as a working group or not? The first one is, if you require an optional feature to make your use case successful, that's totally fine. So if you say, I'm really interested in web transport because I want unreliable datagram-based, not unordered packets where I want to send this from point A to point B, and I need that, and I will take my toys and go home if I can't have it, then that's totally fine. And you should be able to express that when you go to create your web transport session. You should say, these are the web transport features that I require, even if they're optional in the framework. I'm uninterested in having a web transport connection if I can't have this. It's worth noting that because we think that Quick and or UDP is going to be blocked in some percentage of situations for some percentage of users, you are likely leaving them kind of high and dry. And so you might want to provide, if you say I have some other alternative, I can fall back to some existing thing, then that's totally fine. You should be able to do that. Next slide. The next step of that is say you're really interested in this unreliability, but you're not willing to say I don't want it at all if it can't be unreliable. I'd rather have something that works okay, even if it's not my preferred option. And so the second principle here is you should always know what you got. So generally, we're saying this is better than not having anything, but you still want to know, maybe I'm going to make a different decision about how much I'm willing to send. I'm worried about kind of overcommitting if I'm unsure that you know I might create excessive amounts of buffering. So you may want to adjust your behavior slightly based on what's available. But beyond that, you know, if you'd rather have it and it's better than nothing, then you should know that you're in that situation and be able to adjust your behavior accordingly. Next slide, please. The third and last principle here is that web transport over H2 should look very, very similar to web transport over H3. And so we'd like you to be able to have a single API to interact with this. We'd like to solve a lot of the issues that we just spent a significant chunk of time talking about, to wherever possible map their resolutions onto this. So this is not a proposal to make web transport be done all over again for H2. Simply the deltas that are required in order to make it work as a fallback for H2. So as part of that, now that we've tried to leave the Great Transport Zoo, we've rewritten the previous doc to match pretty much exactly what's in H3. So next slide, please. So in order to do that, we've pretty much lifted most of what's in H3. It brings over web transport datagrams and web transport stream. And there's the header block that had been in the streams is no longer present for now. We can discuss that as needed if there's use cases that need it. But fundamentally, it's trying to match what's there. So next slide, please. And I think the real question here is, it seems as though there's data that shows some significant percentage of networks are going to see issues when using Quick, and we'd want to be able to fall back to something. Doing it over H2 seems like a, you know, not necessarily preferred, but strictly better than having nothing at all. The current shape of how it is something that we're clearly flexible on, having adjusted it several times to match what the current needs are. So I think the main question that we'd like to ask the working group is this something that's worth doing? Do we agree that applications that, you know, can't live without the things that they get from having Quick underneath should be able to express the things they can't live without? And similarly, are we in agreement that modeling it after web transport over H3 with, you know, kind of a minimal delta if possible is a reasonable strategy to take?
Go ahead, Bernard.
Yeah. Since the interim meeting, I think I've gotten some information which leads me to believe that web transport over HTTP2 is a good idea. Just speaking for myself, one thing I learned previously, if you'd asked me what the fallback strategy was, I might have said that WebSocket Stream API might have been part of that. And basically that was a WhatWG Streams API on top of WebSockets. And so I would have advised developers, hey, you can create a wrapper, make it look like web transport, but use WebSockets. My understanding is that work on that is not continuing. And so that the implication for developers is they'd have to potentially write their apps twice without web transport over HTTP. Once they'd write it to the WebSockets API with messages, and once they'd write it to web transport, and that's very, very painful. So I know also development experience with the messaging API of WebSockets has not been all that great, lack of back pressure. So My sense is the developers I talk to, they want web transport and they would prefer one API to having to write two very different APIs.
Go ahead, Martin.
I'm trying to read the chat. Isn't it wonderful? So I think that your requirements are absolutely spot on here. And I think that Bernard's point here is exactly the point that's been made by myself and my colleague for a while now, which is that if we're going to build this thing, we're going to build a TCP thing, or it's not going to be any good. So from that perspective, I think this is great work. From the perspective of the technical aspects of the draft design, I threw a few things in chat. I have serious reservations about the approach that you're taking here. And it may just be that it's 5 a.m. in the morning and I haven't slept for a very long time, but I think that we can probably simplify this, maybe. It might not be a strict simplification, but having all of the web transport associated streams and datagrams all packed into the one stream might be a better design, because trying to integrate this with the H2 stream state machine and manage the impedance mismatch between the H2 states and the quick state you're trying to replicate, probably not going to work very well. Just as an example, reset stream doesn't work the same way in both protocols. And so you can end up with some problems. So I'm not really all that comfortable with the idea of adoption at this point, but at the same time, it's absolutely the right work to be doing, and I have no problems with the people doing the work. I have every expectation that this is going to be good, but I'd like to see it just go and have some more discussion about the technical side of things before we go any further. Thanks.
Thanks, Martin. I put myself in the queue, but also, so jumping in as chair, we have 3 minutes left. I'm getting a sense from the comments so far, and what also I've seen from the W3C, that there's interest in this work. So our main question for the working group today is, so what we chose to do for this session is take as much time as we wanted for web transport over HTTP3, and then as time permits, if we have spare time at the end, leave some for HTTP2. We think that that might be a good mechanism going forward, where we keep doing that, and that might lead to like us adopting this document or another document for this same question. So we want to ask the group, does that seem reasonable to people? Are we okay with discussing the idea of doing web transport over something that's over TCP, as long as it doesn't get in the way of web transport over HTTP3? So if you have a problem with that, please like join the queue now and tell us what you think. We're gonna keep going through the queue, but if you have technical questions about Eric's proposal, please take those to the list. We're going to focus on whether we want to be discussing this in the working group, and whether or not people are interested in working on a variant over TCP. So on that note, Yutaka, please go ahead.
Comment on the Bernard's comment. So we are still working on WebSocket stream. That's all.
Okay.
Thank you. Jonathan?
Yeah, so I was commented this on the chat, but I'd say it here too. I'm a little concerned that how much, yes, there's a percentage of endpoints that don't support, won't have quick working code. It's not a large percentage. So I'm a little concerned how much the code that implements this won't get exercised. Which is, HTTP2 is, well deployed, and, that all exists, and is, whereas this is new code in a mostly quick world. So which might leave a possibility for lingering bugs, including vulnerabilities in this web transport over HTTP2 stack. So maybe this is actually a comment to the W3C that needs to be, at the very least, a JavaScript API that says, I don't care if I do quick, for testing purposes, I need to run this, and then pretending that the only thing I can do is
HTTP WebSockets over HTTP, web transport over HTTP2, but I think this is something that we need to keep an eye on, and make sure that this code can get well exercised.
So thanks. Totally agree. One point I'll just say in response is that my understanding of where this would be needed is not for cases where the endpoints don't support web transport, because I expect that anyone who's interested in web transport will support over HTTP3, but it's for networks that block UDP, as Eric was saying. From Chrome, we're seeing like somewhere between 5% and 10% of networks that completely block UDP. And if we're saying that we have close to even 5% of web transport traffic that goes over TCP as opposed to QUIC, that should handle that code path testing, right?
That's true, but I mean, I guess the problem is that that 10% doesn't include the web developers talking to their own web servers. So when they develop their applications using web transport, they're not going to exercise that path, and might suddenly get surprising things happening to them once they deploy and that 10% of people start accessing their website. So there needs to be some way that they can make sure that works.
That makes sense. Thank you.
David, the 5 to 10% is weighted towards enterprise, so it's actually much higher. If you're an enterprise app, it's more like 15 is what we're seeing, 15 to 20.
Cool. All right, so we're at time, folks. Specifically for this discussion, it clearly sounds that there's interest in discussing this. I'm not seeing any opposition to discussing this, but it sounds like adoption, it might be too early to discuss adoption. So what we're going to say is, let's keep discussing this on the list. Folks, please follow issues on, so the individual draft is on GitHub, so please follow issues there. And we'll keep seeing how this goes. And we're going to say that it's in scope to be discussing this. I mean, after all, it is in our charter. And we'll keep allocating as time permits time in our upcoming interims and IETF sessions. But we'll kick the can down the road a little bit for adoption. And Bernard, unless you have some parting words, I think that's all, folks. Thanks everyone for coming, and see y'all. We'll probably have an interim session before the next IETF. We'll figure out details on the list.
Okay.
All right.
Thank you.
Bye, everyone. Cheers.